Hello and welcome to the final installment of my series JMRI Signaling with Digitrax hardware. During the first two parts, I introduced you to the hardware from Digitrax that I used on my diorama. Then I described JMRI and showed you how to populate the turnout, sensor, and signal head tables, draw the layout schematic in Layout Editor, link the track segments to their respective sensor addresses, plant the signal heads in the Layout Editor window, and edit simple signal logic needed to make the signals function in automatic mode. At this point, we could run a layout and have some very easy and straightforward signaling. But I'd like to take it all the way and have a dispatcher interface that would be used to control the main line by granting routes through the use of CTC Signals. As discussed in Part 2, CTC Signals are basically automatic signals, but with logic that holds them at red until a clear route has been defined and requested. Once it is safe to do so, the hold on that red signal is released, the signal then displays an aspect better than red, and the train is on its way. At the end of this part, we will have a modern-looking dispatcher interface and the logic needed to properly control it. We will start by drawing the dispatcher interface, which I refer to as CAD, or Computer-Aided Dispatch. Open JMRI and go to Panels, Open Panels, and open the test track file as before. Now go to Panels, New Panel, and click on Control Panel Editor. This tool has several items we need to make a modern-looking CAD, namely Indicator Track and Indicator Turnouts. Click on Add Items, then Item Palette, then the Background tab. Click on Change Background, click on the black square in the color palette, and click Done. Now we have a nice black canvas to draw our dispatcher board on. Click on the Indicator Turnout tab. If you need to, you can enlarge this window. I drew the icons I'm using in a paint program. You can create any icon you want and save it to the resources directory within JMRI. As long as the image is a .gif type file, you can use it for just about any item in the item palette. I will make a video later showing how I did this in the coming weeks. I already have my icons that represent my indicator turnouts loaded into this tab. So instructions for doing that will also be included in the later video on making your own icons for JMRI. Be sure to subscribe to my channel to get notifications when that video gets published. The turnout on this diorama is a left-hand switch, so click on the radio button, then highlight the system name for the address used to control that switch. Then, in the occupancy circuit field, type in the address of the sensor that we used to detect occupancy on the switch, which is LS104. As the label around the icon says, drag the icon to the panel. Unlike dragging icons around in the Layout Editor window, in this window you can drag them with a left click instead. Simply clicking on the switch icon will then throw the switch. Moving to the Indicator Track tab, move the radio button to the segment you want to add to the board. Type in the sensor address for the occupancy circuit field and drag to the board. I need 3 different segments, each with tagged to the different sensor addresses we used for the track segments on the diorama, one each for LS102, 103, and 101. Enter the sensor information, drag the icon to the board, type in the next address, and drag and drop. Do that systematically for all 3. If you forget which one is which when you drag it to the board, you can right-click on the icon to see which sensor it is linked to. Put them in place around the switch. You can also highlight the icon and use the cursor keys on the keyboard to move them around the panel if you want to get a little more precise with their placement. Once you have all of the track icons placed where you want them, drag a selection square around everything so that they're all highlighted. Right-click on one of them and check the box Lock Position. Now they won't get moved if somebody accidentally clicks on them and tries to drag them around the board. In real life, dispatchers only care about absolute signals at control points and if the logic has released the hold on the signal he requested. The actual color of the signal itself is of no importance, since he wouldn't have any control over that anyways. The dispatching can be confusing enough without the help of unneeded information cluttering up the board. So we won't add the signal head icons to this board as we did in the layout editor window. Instead, we need a sensor icon that has two states, red and green. A red icon will inform the dispatcher that the signal is still held, and a green that it has been released. I already have my red and green icons loaded on the palette, but I do need to define sensor addresses that I'll use for them. We need 3 total, 1 for each signal mast that's on the diorama. Go to the sensor table and click Add. Like the virtual signal heads from Part 2, these sensors won't actually be connected to hardware on the layout, but they'll just function internally within JMRI. Later, I'll use logic to have these internal sensors respond to actions on the layout. For system type, select Internal. We need 3 of them total, so click the Add to Range checkbox. The number to add is 3. For hardware address, use anything that's not going to confuse you with the sensors already connected to the layout or being used for something else. I use the range around 800, so type in 800 in the address field. This will populate 3 sensors with the address of IS 800, 801, and 802. Note the IS for internal items and LS for local net connected items. As more information gets added to these tables, you can sort them by columns or with the local net and internal tabs up at the top. Go back to the Control Panel Editor window, click on Add Item, Item Palette, and then the Sensor tab. I'm using my mast icon that I drew. Again, that'll be covered in a later video. So I move the radio button to that, highlight the system name of one of the internal sensors we just made, drag the icon to the panel. Do this for the other 2 internal sensors that we just created. Put each one around the switch icon about where the block boundary is. You'll note here I'm putting the one linked to IS 800 where the mast A is, 801 where the B mast is, and 802 where the C mast is. However, on this board, I'm putting the icons representing the signals underneath the track they're protecting, not necessarily exactly where they are in the physical diorama. This will make it a little more user-friendly interface, make the job easier by having a uniform placement. There's no question which signal hold was just released in a complex track arrangement. Once you're happy with their location, right-click and lock their position. Also, this icon should not be directly operated by the dispatcher. It's merely for feedback, so right-click again and check the box Disable. Now we can create logic to link these icons to be a visual report of the state of the signals, whether they're held or released. So to do that, we're going to write some logic. So go to Tools, Tables, and click on the Logics window. Click Add, and if needed, check the box next to Automatically Generate System Name. For the username, I'll call it Mast Link. Click on Create Logic and a new window opens up. So just real quick about these logical statements. Okay, a conditional is a logical form of like an if-then statement. Basically, if so-and-so action happens, then this action takes place. And using it's very powerful and will result in some pretty neat stuff that you can do on your railroad, triggering certain events to happen based on how the railroad is currently acting. So click on New Conditional, and another new window opens. The username for this conditional is IS801 mast held. Click on Add State Variables, set the variable type to signal head, type in the username of the signal head 289B, set the variable state to signal head held, and click Update. Change the radio button to execute actions whenever triggered. For the consequent action part, click Add Action, set the action group to Sensor, type in the username IS801, have it set sensor inactive when triggered true. Then click Update. Finally, click Update Conditional to exit that window. Now click New Conditional again, give it a username of IS801 mast released. Click on Add State Variable. Variable type is signal head. The username again is 289B. Variable state is signal head held, and click Update. But this time we're going to click in the negative field and select the word not. Not held is naturally the opposite of held. Change the radio button again and click the Add Action button. The action group is Sensor. The username is IS801. Action type is Set Sensor, but the sensor state should be set to active on change to true. Click Update to exit this window, then click Update Conditional to exit that window. For now we're done, so click Done. A message will pop up reminding you to do what? Save your work. Essentially, we just wrote a logical statement that says, if signal 289B is held, then IS801 icon is red. But if signal 289B is not held, then IS801 icon is green. Let's go back to the Layout Editor window for just a minute. Here you can click on the signal head icon and cycle through the different aspects or colors. In this setting, the signal head is not held to red. There are other ways to change this, but here's the way that I like to do it. Right-click on the signal 289B, go to When Clicked, and change the radio button to Alternate Held. Now when you click the icon, it just toggles the head back and forth from held to released. And if you look at the dispatcher board, the icon for the mast should be green if that signal head is released and red if it is held. Let's do the same process for signal head 289C. Going back to the logics table, click the box listed as Select and click on Edit. Click on New Conditional. Username is IS802 mast held. Click the Add State Variable button. Set type to signal head. Username is 289C. Set the variable state to signal head held and click Update. Move the radio button to execute actions whenever triggered. Now click Add Action. Action group is Sensor. Username is IS802. Action type is Set Sensor Inactive when triggered true. Click Update to exit that window. Then click Update Conditional to exit that window. Click New Conditional again and name this one IS802 mast released. Click on Add State Variable. Set type to signal head. Username 289C. Set state to signal head held and click Update. Don't forget that since this is the release, to click the negative column and set it to Not. Change the radio button and click Add Action. Set action group to Sensor. Username is IS802. Action type is Set Sensor, but remember to change the sensor state to active when triggered true. Click Update, then click Update Conditional. Go back to the Layout Editor and set the 289C icon to alternate held like we did with the 289B icon. And while you're at it, go ahead and change 289A1 and A2 as well. Go ahead and check your work by alternating 289C between held and released and see if the icon on the dispatcher board is updating correctly. The signal head icons 289A1 and A2, they're a little more tricky, which is why I saved them for last. There's two heads mounted to one mast, but being that it's protecting a switch, only one route can be selected at a time. Therefore, there only needs to be one masked icon on the dispatcher board. So go to the Logics table, select, then click Edit. Click New Conditional, username is IS800 masked held, and click on Add State Variable. Set type to signal head, username 289A1. State is signal head held, and click Update. Click on the Add State Variable button again to add the second head, the same that we did the first. Change the radio button and click Add Action. Set the action group to sensor, username IS800. Sensor state to inactive when triggered true, and click Update. Click Update Conditional to exit that window, and then click on New Conditional. Username of that one is IS800 masked released. Click on Add State Variable and add 289A1 and A2 just as we did just a second ago. Click the negative box, change them both to not. But here's a new one for you. We need to change the logic operator from AND to OR. That way, the first part of that statement reads, if 289A1 or 289A2. Okay? Change the radio button, then click Add Action. Set the type to sensor. IS800, set sensor active when triggered true, and click Update. Click the Update Conditional button, then click Done. I'm sure you are tired of hearing this by now, but don't forget to save your work. Test your logic as we did earlier by toggling the A1 and the A2 head from held to released on the layout editor window. If we entered everything correctly, the icon on the dispatcher board, the IS800 icon, should be green if either 289A1 or A2 is not held, and should only be red if both are held at the same time. I'm hoping at this point you're still with me. Don't worry, we're just about done. On the prototype, as the train goes by a cleared signal, it knocks it back down to red. It will remain red until the dispatcher clears another route through that control point. To knock down our signals to red, we need a logic to do that. We'll group these in a logics group separate from the masked linking. So go to the logics table and click Add, name it CP289, and then click the button Create Logics. Click on New Conditional, and the name of this conditional is OS Hold. We'll use this logic to set all signals at this control point to hold anytime the OS section of track becomes occupied. Click on Add State Variable, type to sensor, and type in the username of the sensor address of the detection of the switch, which for us is LS104, and set state to active. Change the radio button, then click on Add Action. The group is signal head, username 289A1, and action type to signal head held when triggered true. Click Update, and do this again for the other three heads that are located at this control point. When you've got those all entered, click Update Conditional. With this, anytime the OS becomes occupied, then all the signals here will be set to red. As a safety net, let's also make a logic that if the switch is operated, either thrown or closed, that action will also set the signals there to be red. This is handy if you have a layout where crews are used to manually throwing their own switches and not used to having a dispatcher do it for them. So click on New Conditional, name it Switch Hold, and click Add State Variable. Set the type to Turnout. The username is the address of the turnout, which is LT1, and variable state is thrown, then click Update. Do the same step again, but set the variable state to closed. Now change the logic operator from AND to OR, change the radio button, and click Add Action. Do the same here as we did with the OS hold logic, adding all 4 signal heads and setting them to held when triggered true. If you release any of the signals from hold on the layout editor window and then throw the switch, you can see they are set back to hold. Likewise, if you release one and run a locomotive past the signal, it too will knock it down to hold. Having your signals set to red is pretty nice, but I don't know about you, I want to run my train. I can't do that on red signals, so I've got to scream at the dispatcher, "Give me a green!" That's easy enough. All we need to do is some more logic. The 800 series sensors that we used as feedback indicators for the signal states, but we disabled them because they're not meant to be clicked on by the dispatcher. What we need is a route request button for each mast icon on the dispatcher board. I created this as a blue arrow. We need 3 more internal sensors, numbered 900 through 902. With those entered, we go to the dispatcher board, click Add Item, Item Palette, and click on the Sensor tab. I name this icon Route. I highlight the IS900 sensor address and drag the icon to the board. Do the same for 901 and 902. To keep things simple, match up the IS900 with the IS800 icon, 901 with 801, 902 with 802. You can see that 901 and 902, those icons are facing the wrong way, so right-click and rotate 180 degrees. Move them into position near the mast that they're going to control. Right-click and lock their position. Instead of disabling them like we did with the mast icons, we actually want to make them momentary so it's more like a button. So right-click, check the box for momentary for each of the route buttons. Back to the logic table, edit the logics for control point 289, click on New Conditional, and name this Route B. This is where CTC signaling starts to get a little complicated. Everything needs to be just in the right order for it to be safe to release a given signal. Think through the route the signal covers. Is the OS clear? Is the switch lined correctly? Is the track ahead occupied? Is there a conflicting route already granted to another signal head? These are all important questions to ask yourself when programming the logic that you're going to do for the routes. When programming these, we'll also talk a little bit about triggers. Let's start by clicking on Add State Variable and set type to Sensor. Username is IS901, since that's the button we're going to use to request the route that protects, that the signal 289B protects. Set the variable state to active and click Update. See the checkbox in the Trigger Calculate column? Anytime you have multiple state variables, for the action to take place, the state of all of these must be true, and any of them that are set to trigger that become true will cause the consequent to take place. In the case of routes, we only want the action of releasing a hold on a signal to take place when the route button is checked and everything else is listed as true. For all other state variables, we'll uncheck the trigger box. Click Add State Variable, set type to Turnout, the address is LT1, and set the state to close. We only want the signal 289B to release if the switch is properly set for the route. Click Update and add the next variable. The type is Sensor, username is LS104, because we want the OS to be clear before the route is to be granted. So set that state to be inactive. Add another variable. That type is Sensor, username LS102, as that's the segment beyond the signal, also protected by the B signal. Lastly, add variable type signal head, username 289A1, set that state to signal head held, and click update. Do this again for 289A2 because we don't want either one of those to be released with a conflicting route in the opposite direction. Change the radio button, and the consequent is signal head 289B, clear signal head held when triggered true. Click update, then update conditional, and then done. Now go back to the dispatcher board and click the route button for the 289B mast. If we did this correctly, the mast icon should turn green and the hold on that signal should be released. Throw the switch and you should watch the mast turn red. Try to click the route button again. With the switch thrown against the route, it should not release or turn green. Do the same process for route C, making sure to have the state variable look for the turnout to be thrown instead of closed, and using the IS902 button for the route, and that it's the only variable with the trigger box checked. Now let's move on to the A route. With this we have two heads, A1 and A2. A1 is the head that governs the route when the switch is closed, and A2 when the switch is thrown. We'll let the logic handle deciding which head to release based on the position of the switch. So new conditional, the username is A route main, using state variables of IS900 as the trigger, LT1 is closed, 289B is held, LS104 and LS103 is inactive. The action is signal 289A1's clear signal head held. Do the same for a new conditional with the name A route sighting, but instead LT1 is thrown, and instead of looking at 289B, it needs to look at 289C. Click Done and go to the dispatcher board and play with your routes. Put an engine on the track, grant a route to the right, run the engine past, grant a route to the left, run it past, just have some fun with it. Grant a route again, but throw the switch to check to see that throwing the switch actually knocks the signal down. Okay, good. Grant the route again into the siding and run the engine past, now back out of the siding. This way you can check all of your routes and functionality of the OS hold logic and the switch throw hold logic. At this point we have a working CTC signal system. Let's docker up the board a little bit, adding some labels, images, maybe some extra buttons. Go to the item palette, then click on Text tab, and on the font click on the font color radio button. Click the white square on the color palette and highlight the text in the text field. Let's type in CP 289 and then put a space and a dash and then the name of the control point, which is INA, I-N-A. Click on the text inside the preview window, drag and drop it to the dispatcher board. You can see here in my video that the color didn't match what I had selected from the color palette. I think there may be a bug in this version of JMRI. Hopefully that will be fixed by the next release. So right click on the text and click the Edit Text Background Attributes. Click the font radio button again, select the white color again, then click Done. This hopefully would have fixed it. But the text is pretty small, so let's click on the Edit Text options again. Don't forget to click the Font Radio button and change the font size to something like 32 point, then click Done. Left click on the text to drag it where you want and lock its position as well. Let's make another text label. In the text field, type in 3 greater than signs and the word West. Drag this label to the left side of the track, do the same to make an east label, and then lock those into positions. One last thing to finish our CAD. If the dispatcher needs to change his plans after a route has already been granted, he might need to revoke that route. We need a revoke button on this board. Let's go back to the sensor table, add an internal sensor with the address of IS700. Then on the item palette, go to the sensor tab, change the radio button to a small jewel. That way it's something different than we've already used. Highlight the address IS700. And drag that to the board. Drop it near the location label that we had made earlier. Make a text label and drop it next to this button. We'll call this text label Revoke. Lock both of those items into position. Lastly, right click on the button and check the box for momentary. Back to the logics table, edit the logic for control point 289. Make a new conditional called 289 revoke. If sensor IS700 is active, then signal heads 289A1, 289A2, 289B, and 289C, signal head held. Now back to the dispatcher board, grant a route, then click the revoke button to take it away. That's it, we're done. This is a very simple CTC system. There are no bells and whistles. We've got the prototype CTC control systems that employ safety features such as time and route locking, call-on requests, switch heater options, electric lock operation, just to name a few. So research your favorite prototype system and get creative with the icons and the logic. If you employ this on a larger layout with other control points, don't forget to have your route logic look to the other interlockings for conflicting routes. Let me leave you with some final thoughts. This video series was not meant to be all-inclusive of every facet JMRI has to offer. As you read and learn what others have done with this software, you'll find many people that have done different ways of doing signal systems on their railroads, maybe using the signal mask features that are built in to JMRI versus the simple signal logic like we used here. I did this on purpose. I feel the signal mask throws you straight into a prototype signaling, whereas signal heads are a very simple and straightforward approach. They allow you to grow your signal system at your own pace. Also, I drew the icons and programmed the logic to create a dispatcher interface within JMRI because I felt it was as close as I could get to the prototype I was modeling. I model Union Pacific, and my board is modeled after their CAD-3 system, which they use currently at the Harriman Dispatching Center in Omaha, Nebraska. While their system is keyboard command-based, I did make mine point-and-click to be more intuitive and user-friendly. I deployed this method on a friend's very large home layout. I've had professional trained dispatchers come and operate the CAD, pleased with how similar it was to what they were used to working with. However, if you're not modeling Union Pacific, there are other add-on programs. One that comes to mind is the Krandic Automated Traffic System, or CATS, which is a free download from Rodney Black and has some cool stuff built in, features like route stacking and track and time. It has a look and feel, in my opinion, more closely to what the BNSF railroad currently uses. Lastly, thanks to a growing community on JMRI developers, the library of icons contained in the resource directory of JMRI would allow you to build an old-time looking USNS CTC machine as well. So that's it for the series. I'm Stephen Hamilton for Signal Up Productions. Thanks for watching.